Welcome to the DIY Honda Garage channel. The DTC code P0120-1C indicates an issue with the throttle position TP sensor A, which is identified as being out of range. This can occur when the output voltage from the TP sensor deviates from a specified range. The Powertrain Control Module, PCM, monitors this output, and when it detects an anomaly, it stores the DTC. The TP sensor is integral to the throttle body assembly, which is responsible for controlling the engine's air intake. Its position is critical for proper engine performance, contributing to fuel efficiency and vehicle response. A malfunction may prevent the engine from operating optimally, leading to drivability issues. Understanding this issue is crucial for effective troubleshooting. The error pertains to the Throttle Position Sensor A, which plays a pivotal role in monitoring the position of the throttle plate within the throttle body assembly. This sensor sends a voltage signal to the PCM, informing it of the throttle's position, necessary for determining how much air mixes with the fuel for efficient combustion. If the signal is less than 0.39 volts or greater than 4.48 volts, it falls outside the expected operating range. The TP sensor is integrated with the throttle body, strategically located in the vehicle's intake manifold, enabling it to effectively monitor airflow. Ensuring the proper functioning of this sensor is essential for optimizing engine performance and emissions control. Several potential causes could lead to the DTC P0120-1C. Firstly, the throttle body itself may be defective, which would impair the TP sensor's ability to provide accurate data to the PCM. Secondly, issues within the external circuits, such as the power supply, VCC3, signal, THL1, or ground, SG3, could also contribute to the error. Short circuits, open wires, or poor connections might prevent the TP sensor from functioning correctly. Lastly, a malfunctioning PCM could be at fault, as it processes the input from the TP sensor and acts accordingly. Thus, troubleshooting should focus on these components and circuits methodically. Several symptoms can manifest when DTC P0120-1C is present. One of the most immediate indicators is the illumination of the check engine light on the dashboard, signaling an issue that requires attention. Furthermore, drivers may experience an unresponsive throttle, where pressing the accelerator leads to little or no increase in vehicle speed. This symptom is a direct result of the throttle position sensor's failure to communicate properly with the PCM. Another common symptom is poor acceleration performance, where the vehicle struggles to gain speed or respond promptly during acceleration, potentially leading to safety concerns. Recognizing these symptoms early is critical for timely diagnostics and repairs. In the first troubleshooting step for DTC P0120-1C, begin by turning the vehicle's electrical system to the on mode without starting the engine. After doing this, you will be required to use the Honda Diagnostics System, HDS, to check the output voltage of the TP sensor A. The expected normal voltage reading should be roughly around 5.0 volts. If the HDS indicates a value that is less than 0.39 volts or exceeds 4.48 volts, it confirms that the failure is replicated, thus validating the DTC present. This initial step is essential as it establishes a baseline for further investigation into whether the problem originates from the sensor, the throttle body, or perhaps even the PCM. For Step 2, disconnect the throttle body connector, ensuring it is completely detached. After disconnection, set the vehicle to the IG mode and measure the output voltage from the TP sensor again through the HDS. This step is critical as it allows you to verify the voltage without potential interference from the throttle body's normal operation. A normal condition would reflect a voltage reading close to 5.0 volts. If abnormal readings persist, it may indicate deeper issues either in the sensor or in the associated wiring. Properly documenting the readings during this step will provide vital information for subsequent troubleshooting processes. In this step, continue with the throttle body connector still disconnected. Utilize a jumper wire to connect terminals number 3 and number 6 of the throttle body connector. After making this connection, turn the vehicle to the on mode once again while monitoring the HDS for the TP sensor A value. A proper and normal reading should indicate approximately 0 volts. If the HDS shows this expected value, the issue likely lies within the throttle body itself, indicating it may need replacement or repair. Conversely, if the reading isn't within normal parameters, the problem may stem from other related components in the circuit. This diagnostic step sharpens the focus on the throttle body or the broader electrical system involved. For step 4, the next diagnostic procedure involves a thorough inspection of the VCC3, THL1, and SG3 circuits, ensuring that they are functioning optimally. Begin by keeping the throttle body connector disconnected, as well as the PCM connector B disconnected. One key parameter to assess is the wire resistance. You expect to find less than 1 ohm when inspecting these circuits while the vehicle is in the off mode. Additionally, it is crucial to check for any short circuits between these wires. Each test condition has specific outcomes. For example, if any short circuits or high resistance readings show up, it could highlight a wiring issue requiring immediate remediation. Establishing the integrity of these circuits is fundamental in pinpointing the cause of the DTC. In the final step of troubleshooting, step 5, after all previous inspections have indicated normal conditions, turn your focus to the PCM itself. If all associated components and circuits are verified and functioning correctly, it strongly suggests that the PCM is at fault. This system serves as the brain of the vehicle's engine management and is essential for interpreting signals from various sensors, including the TP sensor. A malfunctioning PCM can lead to erratic performance and trigger recurrent DTCs. It becomes imperative to replace or reprogram the PCM as necessary, confirming it is adequately meeting the vehicle's operational demands. A careful review of the previous inspections provides evidence supporting this diagnosis. The final repair verification process for DTC P0120-1C involves systematically ensuring that all repairs have successfully addressed the issues identified. Begin by clearing the diagnostic trouble codes, DTC, from the PCM to reset its memory. Then, proceed to recheck the TP sensor A values using the HDS. Ideally, these values should align with normal operational ranges after the repairs are made. Conduct a road test to confirm that the vehicle exhibits proper throttle response and overall functioning. This verification step is critical. It validates that the issue has been resolved and the vehicle is free from related errors, ensuring safety and reliability for the driver. Preventive maintenance is crucial to ensuring the health of the TP sensor and throttle body to avoid future occurrences of DTC P0120-1C. Regularly cleaning the throttle body can help minimize carbon buildup, which may obstruct the throttle plate and affect sensor readings. Additionally, it's essential to periodically inspect wiring harnesses for wear and tear, which may lead to shorts or broken connections. Keeping an eye on sensor performance through regular diagnostics will enable timely identification of any issues before they snowball into significant failures. Implementing these preventative measures enhances vehicle longevity and optimizes performance by maintaining a seamless interaction between the throttle body and the PCM. In conclusion, the DTC P0120-1C signals a critical issue with the throttle position sensor A, affecting vehicle performance. Understanding the role of the TP sensor is paramount to diagnosing the problem comprehensively. Following a systematic diagnostic approach allows for the identification of potential pitfalls in the throttle body, external circuits, and the PCM. Moreover, regular preventive maintenance can prevent this type of failure from reoccurring, ensuring the longevity and efficiency of your Honda CR-V. By being proactive, owners can safeguard their vehicles against unexpected issues, ultimately leading to a smoother driving experience. Please like and subscribe to the channel. See you next time!